The session today started by just identifying the fact that when we say the word xylanase, it's not like vitamin A. There's only one vitamin A. When we say xylanases, there are many xylanases, completely different characteristics. And when you look at them and the way they work in the animal, the way we assay them, the way we're able to assay them, and how they survive, not just pelleting of the diets that we make for our animals, not only just surviving through the intestinal tract, they all differ in their abilities to survive these processes and these rigors. And as a result, it's unlikely that they'll all deliver the same response in the animal. Indeed, we heard later on in the day that these xylanases produce different kinds of end products. So an enzyme, like a xylanase, attacks something, which is xylan, and it produces smaller fragments called xylo-oligosaccharides. And today we learned there's a whole plethora of these xylo-oligosaccharides, and they all have different physiological functions in the animal. So a very complex field, and it means we've got to be very careful when we use one word, xylanase, to encompass everything in the whole story of the NSP debate.
NSPA's enzymes are effective even in diets containing a phytase.
It's one of the key objectives was to tell our audience that viscosity reduction was one of the key mechanisms of actions for enzyme use, and that was actually the start of the whole feed enzyme industry to rely on it. But I also demonstrated at the end that there are a lot more to it than just reduction of viscosities, and that was talking about replacement of antibiotics and other secondary effects of enzymes. That the enzyme development followed a very interesting pathway. So from simple understanding of viscosity reduction to looking at the other effects of enzymes, and some of the effects were not even thought of at the beginning. So then basically leading a pathway into the future about enzyme research. So I just wanted to demonstrate that the benefit of enzyme use in the industry is massive. And you're talking about, and somebody quoted $5 billion effect globally.
They were fed to the animals, and you see a nice range in feed conversion. And there was no interaction between the quality of the corn and the enzyme addition.
From an academic perspective, the conference has spent a lot of time discussing how we properly design these trials. I mean, a lot of learnings as to what we can do better in the future, so that the information from the animal trials is really valid and reliable.
And combined together for the single and multiple activities, out of 49 papers, only 6 papers were found to include phytase into the control diet. And combined together, the interpretation is quite open to question.
The information that's generated around them is generated in the absence of an ingredient they commonly use. And there is an interaction between these two ingredients, the phytase and our NSPAs, or xylanase. And as a result, I think there was a great deal of interest in understanding why these two don't add together, and questions related around the mechanism as to what actually goes on in the animal as to describe why they don't add up. 1 + 1 = 2. It's 1 + 1 is equal to about 1.6.
He exploded some myths we have. That things like bifidobacter is good, and he tells us bifidobacter maybe isn't good, but there are other bacteria, butyrate producers, that are good and are important for health of animals and probably also health of people. So I enjoyed Johan's talk.